Hello everyone, welcome to my YouTube channel. This is Wahid Lutfi. I'm going to be presenting you today Windows Task Manager versus Linux top command versus Linux htop command. In particular, I'm going to be discussing about the Task Manager for Windows operating system and Linux top and htop command. Without further ado, let's get started. The thumbnail that I presented here, I have a task manager on the left top side, and then on the bottom top command running on Linux Ubuntu, and also Linux htop command, Linux Ubuntu on the right side top corner. But I also present you today presentation for Windows 11 Professional Edition. Also, htop and top command are both discussed on Linux Ubuntu as well as Red Hat Enterprise Linux 9. So stay tuned, you're going to learn a lot from it. And without further ado, let's do the continuation of this nice presentation that I prepared for you. What you see is a task manager interface on Windows operating system. I will later on demonstrate everything in detail. And this is what you see when you open a task manager. You see processes, performance, app history, startup, users, details, services, all on the left side. For example, here I open performance, and I'm currently looking at CPU. That's why central processing unit is selected. The detail on the right side is not shown here, but I'll show you on the actual presentation. This is just for the thumbnail and the presentation. So I took a bigger picture here. Similarly, for the top command, you can see the top on the Linux Ubuntu, very nice coloring and based on the terminal interface that you select. Also for Red Hat Enterprise and Rocky Linux, you do have option to just set up the colors, but by default, Linux Ubuntu has a little bit better coloring. You don't have to do much to set it that environment because it is already selected the right coloring for the fonts and everything. Obviously, the fonts I make it bigger to look nicer for you, so you can read it, all the information. And then later on, when it comes to the actual presentation on the top command, I will demonstrate every little details that are there that are going to be discussed. So this is the Linux top command on Red Hat Enterprise. As you can see here, I also took a picture of activities and then the whole interface. The nice thing about Task Manager, top command, and htop command, they all generate dynamic data output. So it shows you all your resources and processes and threads that are running, tasks that are running on Windows. On Linux, we'll call it all PID, process ID, and then we will just discuss those ones. So whether process ID, whether the child process, whether the parent process, whether the system daemons, and so on. Excuse me for a second. So, and then you can see the htop command. It is a little bit like similar to a GUI interface, but it's not fully graphical user interface. It is a TUI, a text user interface. So you press F1, and then it will just present you information for help, and press F2 to set up the setup, and then if you want to press F5 to get the three of them, I will demonstrate some of them. And then similarly on Linux, Red Hat, the htop command has like that kind of coloring and all those options that are there. And the nice thing about the htop, it shows you by the process number, the process 0 through 4. You can tell that I have 4 processor. I'll show you the usage of the process and memory and some other commands and later on details. So without further ado, again, let's get to my website. This is my website. MyWebUniversity is the YouTube channel. Yesterday, I posted this one, Unix grant sudo access to GOAT, greatest of all time players. but it's actually more of a Linux administration. And then you can change a group go to developers, to application, to network admins and everything. Then you have given him access, and based on that one, you just are able to do it. Whether you're on Linux or Red Hat or Rocky, sudo will give you more higher privilege as root, which stands for switch user do. Sudo does not stand for super user do. It stands for switch user do. Just remember that one. So here I'm also doing the same kind of technical training for MyWebUniversity and for C language, which is my mother tongue that I was born in Kabul, Afghanistan, and I'm very proud to support the Afghan community for learning and getting educated and making engineers, producing a lot of people that they cannot afford to go to college, and due to whatever reason the government is corrupt or people do not have option to just go, especially the girls cannot go to school and all that detail. I forget about all of that one. I try to do my portion to support the community for people that they are willing to learn, and they and inshallah God will help us all, and they will start learning and educate, and so they can get a job and support their family and loved ones, and at the same time help the technology in the country. So I have this one and also in English, as well as in Farsi, the English version. You guys are seeing it, the Farsi that Afghan and Persian people in Iran and Afghanistan and Tajikistan, they all speak Persian language, which is similar to Farsi Dari. In school, we used to study Dari, which is Farsi, and then you will learn all this the detail. As you can see, I already made a Windows Task Manager, and on this one, I made a portion of the Linux htop and top command discussion, but I'm gonna go to further details on the video that I'm just making it today for the English version. So that will be posted here at MyWebUniversity. And then if you watch this one and then you're now ready to learn it in English, just come here and then watch the same video with more details in English, and then now you're an expert in the Task Manager, Windows Task Manager, as well as Linux Ubuntu, as well as Linux Red Hat. So I'm going to move this Zoom here so I could just see the screen better. And then now I'm gonna go first to the Task Manager. So by default, when you have the Windows operating system, if I just type in about here, about your PC will tell you what kind of operating system you're running. As you can see here, it says Windows 11 Professional Edition. And that's my operating system. All the resources, everything like I showed you on previous videos, whether you want to look at the type of hardware that you have, or the memory, or the name of the host, and what type of core you have, and how many of them you have, and how many gigabyte of memory. All of that one is here, as well as on the system information. From command line, you can run the system information. From GUI interface, you can get that one. So you can get all of these ones and look for everything, and then just look at the details. So at the same time, you can also look at the device manager. Device manager on Windows, that will tell you all the resources that you have. For example, if you're looking at the processor, you say what type of processor I have. You can see it is a 3.4 gigahertz speed, and then it's a 11th generation Intel i7 core, and then I have 8 of those cores. So altogether, they're very fast. And then similarly for other things that if you want to look at it, you can get it from here. So if you just want to open a task manager, since I have Windows 11, by default, whether you have Windows 10 or Windows 11 or any other one, Task Manager gets installed on your system. So you just right-click in somewhere in the status bar, and then as soon as you right-click, you have the Task Manager setting that you can go and set some stuff. Like for example, this Copilot preview, that's the AI stuff. If you want to disable it, you just check it on there. But any of these things that you enable or check it, it's based on the taskbar and manager and icon. They run as processes. So when it's called task, basically everything that could be considered a task. A service is a task, a process is a task, and everything. So a task, when it starts, for example, Microsoft Edge that I have is 16 of them here. You can see that. And then if you want to expand this one, basically you could see that all the later information, that everything that I have open, it will just do it. And then the same thing with file manager, like for example, Windows Explorer. If you just look at this Windows Explorer, this is another process. So for each of these ones, you have the under the task menu, but just for a process, you have option to spawn off a process, run new process. You click here, for example, if I just want to say WordPad, just open a WordPad, it's opening WordPad. And you can just say, well, if you have Microsoft Word, for example, you just type in Word and it will open Microsoft Word for you. Word. So the word is not recognized here, maybe because of the, you have to type in Microsoft Word or WinWord, whatever the name is, then you have to type that name. And I type in WinWord was the accurate one. So if I just want to open a new one, you could just see Microsoft Word is there. Now, if I want to close this one, and then earlier the two word, that command that was there, it was showing. I come back on this icon, now I have the task manager again here. So if I just type in here another one, Excel, and now Microsoft Excel opens. So at this time, if I minimize this window, and then you can see here, Excel is here. I can just come back here and maximize it and open it and use it and everything, or I can close it, or if I just say, put it here, but I could right click here, say end task. End task would just kill it. It would just close that Microsoft Excel, it just closed. Similarly, if I just have a PowerPoint presentation, I can open a PowerPoint task by just typing PowerPoint. You have to type it correctly, and if it doesn't happen, maybe because the name is not PowerPoint, again, like Microsoft PowerPoint. So if it doesn't start here and you don't know the name, you can come in here, say PowerPoint on the search, and then PowerPoint, this one will just open it here. As you open it, you could just click on it. Notice that I have two PowerPoint here. One is my actual PowerPoint presentation for this one, and the other one that I just opened here. So if I want to close that one, I have other option that to just look at the two PowerPoint here, which one is which, and then look at this one. And then from the task manager, sometimes it's difficult for you to see which one is the one that you just spawned and which one is the one that you have lastly running. Sometimes you can get it by process ID, or when was the time stamp of one versus the other one. But it's much easier here to just say, this is the one that I want to stop. And then now that one is stopped. If I just go back here, this one only will have one of them. And then if I just close this one also, let me just go close it from here and just say close this one. Now the PowerPoint presentation is gone. As you can see, it's not there anymore. Similarly, you can just open up like calculator, anything that has the exact program, you can spin it off. What I mean by the .exact extension, so if I just go on the command prompt, and just on Windows, you can go to C drive and then Windows system 32, so clear screen directory store.exact. This one tell me, show me anything with the extension of .exact. The file name does not matter what it is. I want to say it is executable file. So it listed 631 of them. Like Xcopy is one of them, and for example, clear screen and say directory calc.exec is 1. So if I type in calc here, because the extension is .executable, it opens that calculator. Similarly, if I say calc.exec, it opens that one. But because calc.exec and notepad.exec and everything is in the path, echo percentage path, environment variable has the Windows System 32 path, then it doesn't matter where I am on the machine. I could be here and say calc, and it opens the calculator. And I don't have to give the extension here. Similarly, Notepad, I don't have to give extension for it. Similarly, like WordPad and so on, all of that executable. So Windows System 32, clear screen, and then as you can see, I could type in uppercase, a clear screen, or a lowercase or uppercase. Doesn't matter. Windows is not case sensitive, so it will translate everything in assembly language to uppercase before it executed. So here I will look for all the dynamic link libraries, .dll. So you can see there's a lot of them. But if I want to just say, let's get the executable, and then I want to just say 5 more, so I can get one screen at a time. Notice that all of these executable I can run, like add job and address resolution protocol, ARP address, and all of those commands are part of the Windows available, check disk and so on. Calculator, you can see that there's a lot of them. So like I showed you clear screen, the ARP.exec, this one, if I say help ARP, this one address resolution protocol, it is basically question mark this, it tells you that 5 more. It gave you the MAC address and then cache everything. I'm not gonna run the command because I don't want my local MAC address to be shown on the system, but I'll tell you if you just run ARP -A, it will tell you, and then ARP -S for setting a static entry and so on. So you could have those files on the executables. I'm gonna close this one, and I show you that if here you type in Notepad, it opens the Notepad. And if you, I think I already typed WordPad calculator, I already typed in everything, it just opens those processes. Now this calculator is open. Here, if I just sort it by name, I can search it by the name by typing here, say, under the search, say calc, and then I find out the calculator. And right here, I can say end task. Notice how easy it is and within Microsoft Task Manager. So when I say compare and contrast, I'm not gonna just say that one is better than the other one, but there's a lot of stuff on Windows that I really like, and because it makes it for an end user much easier to just terminate without knowing too much about the system. So a lot of it is already a button and click and other ones. So in that sense, like a top command and htop command, it will show you those details and it will tell you certain things, but you have to know the system in order to do a lot more than this. On Windows also, there are things that you cannot do it within Task Manager. You have to write a PowerShell. I could show you how to do that one and certain things that works like similar to Bash scripting on Linux and or Unix, then you could do a lot of those things and get details of process tree and so on. So like here, for example, if I look at the processes on command prompt here, there's a command called tree, but tree is different than a process tree. So tree command, if it just give you like a tree structure of all the files for the directory that you are. So if I go on the directory of temp and then clear my screen, say, okay, that this one is the directory, now show me a tree of that one. You can see tree of that one is just says Python and then PyCache and shared folder. So if I just do say, show me all the files also, it shows you the files. And if I do a 5 more, you could do get the information. This is like in files, but if I want to see it in ASCII, I could do /A and then it will just you saw the bar change. So if you want to see 3 commands / question mark, it will just help you saying that this command, but this is file level. It is not process level. On Linux later on, I'll show you the PS3 and stuff and P3 and other ones that I also will show you on the top. So here, when you're going here for all the processes and say, show me all the processes, and then at one point you say, let's sort it by order of these ones. And if you look at the Explore, for example, and you say expand it. Let's see if the option is there. Restart in task. I don't want to stop the Explore because this is my main process. Like here, that all the resources that are connected to it, you could see that the process of file manager and everything on the file system. Some of these processes are system related, and then you could just have user processes that are spin off by you. Like for example, a calculator. If I just start a calculator process on the run and say calc, and then just look at the process calculator here, and then I just look at this one and then say right click here, and then you can see it has expand. So this is how much you get information here to do it. But then also on the command line, like if you could see the task manager here that was showing calculator, you can also do a clear string here and say task list. So now notice the task list give you a lot of the task. And then I could say, well, I'm interested only on the task list when it is something with calculator. So I'm looking for a task list that the application name is task calculator app.exec, and this is the console, and then this is the detail. So if I just make this screen wider enough to show this detail, this is the process ID or task ID that I could kill the process calculator. So if I do task kill /PID, and then we say 2384. Send termination signal. So at this time, the calculator is still open because the termination signal is signal 15. By default on Linux also, if you just do this, it is going to try to gracefully close this session. It's not forced yet. But if I just exit it, this will just say, okay, that signal now is closed. But at this time, I want to just force it so I don't have to wait for it. Programmatically, you do /F. /F force it, and now there's no more calculator. So if I go back here on the task manager, you can see the calculator is gone, no result found. So that is good. And then if you just delete this one, remove it, you can see the process are there. So there are some tools that are here that are really, like for example, if you look at the performance, it gives you CPU usage and then how much of your CPU is utilized and what is the speed and what is your base speed, 3.4 gigahertz, and then what is the number of processes that are currently running. So under this, all these processes, the total is 212 of them. But inside these processes, you have a small threads. Small threads could be another code within the, like for example, if you open Microsoft Word, inside the Microsoft Word, you take a portion of it and you highlight it and you just want to change it to a different colors or those ones will be running as a small threads there. Or you could do a file print, it will run another thread. So a process could have a parent process, a child process, and it forks many sub processes. Later on, I will show you on Linux also how you can trace those ones in details. And as you can see here, the number of threads is 2,470 for those 212 processes. But there's a lot of file handles. And Linux and Unix and Windows, every file, the file descriptor, we call it, or file handle, it has to open. On the Unix, Linux is called inode structure. The file node has a file node handle. It has a number that is specifically read and write to that file handle every time you do work on the resources. So then there's also this basic speed and all of that in terms of how much cache and how much memory. The uptime of your system is also here. On the command line, you can also get the uptime command here, say system info, and then find /I, and then uptime. So you can get the uptime from the system. If the uptime is not there, look for the boot. When was the last time your system was booted? And you can see that the system boot time was this. It has been up for since 10:50, 30 p.m. Of whatever date it was started at 222. And then today is 224. So that has not been shut down for the past 2 days. And then you can see the boot device, the version information, the volume, the CMD, the actual build version. Like if I just go out of the CMD, clear screen, system info, you can see find /I and then say OS name, you can see that it's Windows 11 professional, and then you can see the memory. So all of these resources, like you get it on the task manager, you can also get it from the command line. Model, the architecture of the machine is 64-bit Intel in this mini T11 generation. It's at 3.4 gigahertz. All of that one is there. So if I close this one, and then I just show you some more on the memory, for example, it tells you like 15 gig is used, 16 gig available. And now notice that this 15 gig, because I'm running a number of virtual machine. So this is a Red Hat virtual machine, and then I'm going to later on log in, and this is a Linux Ubuntu virtual machine. And how they are been showing here, you can see this is one of them, the Red Hat. As you can see, is the Red Hat is algorithm, and the resource that I've given is 16 gigabyte of memory, and then 4 processor. Similarly, for this one is if you look at the setting, this one is also 16 gig with 4 processor. So these two, this one is power off, but Ubuntu is running. Ubuntu is 8 gig, and then this one is also 16 gig. So the memory on the algorithm is a lot more versus the Ubuntu. I allocated just for whatever reason. At that point, I did it. And now notice by them running, I still have 16 gig available. What does that mean is the memory is getting dynamically allocated on the system. So the memory is very efficiently by the host operating system. In this case, the host operating system is Windows, and the guest operating system, the virtual machines, or Linux Ubuntu, and Red Hat Linux. And I will just show you on each one of them the memory first before we just jump into the rest of the details. So if we look at your resources, I'm going to log in on the Red Hat machine first. And as you can see here, if I just go Shift Control Plus, this gets a little bit bigger, so you can see 3-H and human readable. It says that the memory that is allocated is about 16 gig, and 1.6 gig is used, and 12 gig is available. And then similarly for swap space, 7.9. So if I say, let me see a cat / proc / CPU info, and 5 more. Central processing unit information is read from proc file system. This file is actually a 0-byte file, but when you cat it, it reads the contents from memory. So you are going to see how many processor you have. So there's 4 sibling, which is 4 CPU, and then altogether allocated, and you can see CPU 0, CPU 1, CPU 2, and CPU 3 should be here, and there's no more. So that is for those CPUs. You can also run the command here, ls CPU. less CPU. You can get that one. You can see that 0 through 3, the number of processors. And if you want to get more detailed, like clear screen and say LS CPU and then grep minus I model, then you can see the architecture's 11th generation, similar to the way we looked at it, 3.4 gigahertz. All that information from Windows, you can also get from Linux here. A lot more details are done here. So I'm going to run htop here because when I did a pre-h, I showed you that it's about 16 gig and then 1.5 gig is used. Notice how a nice htop does. Top shows all the 4 processor here, 0 through 3. And then the memory, it says 1.23 gigabyte is used out of 15.4 gig, which is almost 16 gig. And then the swap is 0K 7.8 gig is swap space available. At the same time, how many tasks are there? Altogether, these tasks are also called process, which are these process ID for them. And then the number of threads that are in the process. And then how many kernel threads that are there. KTHR is the kernel. The load average, what is the load average? Is 0.03. That means the system is running very, very efficient because I'm not running any application yet. But if we run it, still the system has a lot of resources available. It should be there. Uptime is the past 2 hours. The system has been up. Today, current date is Saturday, 2024, and you can see the times stamp is good. So this is on the top. You get all the processes here, and then the process IDs are here, and then the parent process ID is on the next column. So each process has a parent process ID. The main process ID of every process is 1, which is system D. On the system 5 release 4, we used to call it a net. And then on the system D, is the 1 process ID is called system D. And then on the owner of the process who is running it is root or dbus or wahid or wherever the user spawned the process, it will show the owner here. The priority, this is stand for priority. The higher the priority, the lower the speed. Then 0, the number, like any process that you nice it with a higher, lower priority, it runs first in the foreground. And then the virtual memory, how much it takes for the process, how much in resident portion, and how much in shared. These are memory consumption on the system. When the process gets loaded, it gets the data of the program gets loaded on the resident portion of it. The virtual memory is the part of the memory that is in the heap that grows or shrinks based on the data coming in that grows, and then or the data swap out and it gets shrink. The resident portion I talked about, the shared memory is the memory that is shared with the shared object files and dynamic link libraries. This is showing the state of the process. If it is S, means the process is in sleep mode. If it is R, means running. This is CPU usage, how a CPU extensive the process is. And then memory usage, it shows you how much memory has consumed. And the time stamp that it has been on the CPU. And then the last part is the actual program. So if you look at the process 1, if you go to the right, this one, it shows that system D with these parameters are up and running as daemon. You see system D, because it's D for daemon, it runs from user lab system D, and GB is 1 argument, so it's root and system, and all the details are here. So now you can see for one process, if you want to trace that one process, you can get a tree of it, or you could just say quit out of here and say htop minus P for process and then 1. So now only shows that process 1. And then you could say, okay, let me just go on there. Notice that this one is giving you that htop detail, but at the same time, if you quit out of this one, clear my screen, htop. And then notice on the bottom, of this one, which you don't see, there's function keys. Let me resize this one to smaller so you can see everything. I'm gonna just close this one. I'm gonna open a new terminal by clicking on activity. And then I click on here, and then now I am here. So I'm going to just make this screen as wide as I can so I can see everything. I'm gonna run without any size increase htop. And now notice that htop has these function keys. These function keys, if I just do the same thing with htop-p one, and now the process one is showing, but the function key is showing me help. So if I press F1, it's gonna give me all that detail that we just saw on the CPU information and that number of swap, how much it is, and all that detail. Each one of these it tells you how to use a stop command for help, like what is the stab means, how to use the arrows and everything. But I'll show you right now. So if I want to just go on this system user, notice that I'm not getting any details information for this process one, right? So in Linux, you have a command called ps3, but htop also has the setup information, F2. So if I just press F2, and then I say, okay, for the F2, give me a tree view or a not tree view or just regular one, and then I just press enter. Notice that this one is now giving me this kind of detail. But let me just go say, show me the threads also. So F2, and then I'm going to select on tree view, as well as tree view is always sorted by process ID of htop behavior, and also tree view is collapsed by default. So I don't want to collapse it by default. I just want to see that option here. Okay, so this is still there. Let's see if the collapse thing is gonna give me more detail. But I will show you if it doesn't, what you can do to get detail. So right here, you are not able to see the details of it. Obviously, there's some other button here that you can go on the headers, and then number of columns or metrics, what you want to see. Based on the information, you can set up these ones. But I'm very, very efficient on running commands rather than using a GUI. So I will show you, for example, on the process tree, how you can get a command like what is PS3. PS3 stands for a process stream tree. So this one is just saying nothing appropriate, but actually let's see if process tree is there. So man PS3, yeah, man PS3 is there, but the what is command, I have to populate it, and then we get the output for it also. But it displays the tree process. So whatever process you give it as input, it is giving you a process stream tree. So at this time, I want to see it with one. Notice by default, if I do this one, pipe more, it will show me the system D is the main process. Then all these other ones become child processes that are forked from this one. And it called this model manager, and then model manager called this one, and it called network manager. And everything that on your system is just controlled by a system D. It's the parent of all processes, the mother of all processes. And so everything is their child. So if you look at the PS3 in more detail, I could say PS3 minus T, and then minus P process one. Notice minus T, it gives me the thread number. The T in lowercase number, it gives me the thread number. So if I go to the screen and then do this one, 5 more, notice that for every process, process one, it had forked its process ID 15, 15, it forked this one, and then so on. Each one of them. There's details of each of these threads that are coming, sub-processes and everything. But in order for you to get a better picture, and instead of getting a process ID of 1, I could just say, let's look at the 815. that has a few of them. So I could say, and instead of this one, I say 815. And now notice that 815, 815, it forked 827 and 819. There's a noise command, you say ps minus ef grep 815. You can see that 815, the parent process of it is 1. And then 815 was a spawn, but 815 also have these other two grep command. So I could say grep minus v grep. I don't want to see my own grep. So process ID 815 only has a parent process ID 1. But if I go the same thing with process ID 1 only, then I have a lot of processes that are child process of 1, each one of them. So this 2 for the 12 has a process ID of 2, which is also system level process. So I could say htop minus p 1 and 2. Show me the process ID 1 and 2. Unfortunately, the 2 is not showing here, but you could do like top minus u minus p, and then 1 and 2. Let's see if top shows up. Yeah, top shows up, and that's a kernel thread. So process ID 2, you can trace it by running either top or htop, and then when you do the htop, for example, you could do top minus u and then Wahid. Look for all the processes that are running by Wahid. Or you can say htop minus u Wahid. And then similarly, you get all the processes that are forked by user Wahid. If you do top minus u root, you could get all the processes that are forked by root level. You can see all of them are root. And similarly, if you change it to Wahid, you will see the same thing. And then since that syntax is there, whether you use a top or htop, both of them work for that one. So if I just want to get root processes, I get the same thing. Similarly for the process ID of them. But with the PS3, you can get a lot more information. grep2, notice that grep2 is all of them has a lot of the process that is there. So now if I just say grep minus w2, then it's going to show only the parent process ID that is 2 or 1 for those ones. And then since 1 is here, but in this field we have a 2 matching. So if I want to just say, show me everything that has only the third column as process ID 2, then I could get that one. So I could say, let's see, awk print $3, and then say after that one, we could just say at this time I'm only interested on 2s. So grep w2 will just basically show all of that one, but I need to close that single quote here, and that will show those information. But since I'm not getting all of them, I could say print all the details there. And then again here, this other one is there. I could say when this parent process ID is the 2 is showing on the third column or fourth column, ignore it. You could do that one. And then you have to write a little bit script to just search for whatever you want, or you could just say something like egrep minus v 2:1, and then also you don't have to write the script. You could do this something like this, dash F2. So you could just do this, and then those ones will be eliminated, the extra one. Without this command, you see a lot of these 2 here, and then dash F. But with this command, you could just say, I only am interested on this column. So there's a lot of stuff that you could do. And then you notice this W2 is there. You could do the same thing here with the extended grep or expression grep. Grep It stands for global regular expression print. You can do either this or that, or this is an or statement. You could say dash W and two, and then that will also be eliminated. So now you have this. And if you just say 5 more, and then you can see that the first one 0, and the kernel thread, but that's the main process that it was, kernel was started with process ID 0, and then the child process is 2, and then 2 is also a kernel thread process. So you could get all this related information. You could also say PS minus EFA grep for grep minus I for system D itself, to see whether the process that has the system D in it, you can see all of these ones has system D, user lib system D, whether it's udev for login or dash user or HGB, the main process, all of them will be there. And so whether you do it with top or htop, like if I run top command here, you could see on top, you have all this information about the system is up, since when, the load average is what, if there's any zombie process, and how many tasks are there, what is running, what is sleeping, and then how much memory you have for the user level as used, how much for the system, and how much for noise process, idle process, wait, and high processes. This is like swap in, swap out. All those details are there. And memory, how much is available, how much is free, and how much is used, and then how much is in cache, swap space, then the process IDs, and then the users and everything. So in top, for example, if I just run a Firefox process here, say Firefox, first of all, say which Firefox. You say, okay, Firefox is a browser. I can spin off a user bin from Firefox, and then with ampersand, and then that will just spin off Firefox for me. At this time, I'm just leaving here. I'm just gonna go to, let's say, youtube.com/@MyWebUniversity, my YouTube channel, so that will just stay there. And then notice with Firefox, in addition that you have these nice things that you can just look at the processes and everything, you can also go to websites. So if I go to google.com, you could just open a term if you want to just do something. Okay, got it. So I'm not gonna just sign in or anything at this time. So I will just close this one. I don't want to be prompted for that one. So let's say I'm going to go HTTPS www.mywebuniversity.com. This is also my website that I built a lot of things on a secure page, and have videos, and the entire book that I wrote on Linux Ubuntu is available online, about 13 chapters. There's thousands of technical documentation that you can get on Linux on PDF format. You can see it's very nice, sorted, everything. You have it for Linux and Red Hat, Rocky, everything. You just get a PDF version. You can even generate it dynamically by clicking here, dynamic generation. So if you're looking for like system D, for example, just type in system D and then click here, and now you have the system D manual pages. If you are looking for like GCC, for example, for GNU C collection compiler, type in that one, says submit, and then you get this PDF file, and then you just open it and look at it. Similarly for Python, similarly for Bash. So let's say you're learning Bash scripting, and then rather than buying a book, and here's the entire manual page. I learned from manual page everything that I'm teaching you. I read a lot of these ones. Believe me, there's every for statement, while statement, Bash and Corn shell, on Bash and C, C++, Python. Every one of them functions and how to write it, I learned it from these manual pages. So just understand these are your friends. You come in online and start learning. So assuming that this Firefox, I want to kill it from the, I can close it here as many as I want, But I can also go back to my terminal here, and then I say, okay, so this one top, I'm running it with the background Firefox. Since I put the ampersand, I press enter, I'm gonna still get the same menu. But I can also spin off another terminal here and then work on that terminal here. So if I just do a little bit shift plus, and then I say, okay, let's look at process grep minus I Firefox, and then grep minus V grep. Notice there's a number of processes there. So one easy way to do it is like pkl command Firefox. And then now Firefox is closed. And then you can see that this command we run earlier, it is not giving you any information. So if I just do another way, Firefox, let's say I go Firefox, and then on the background here, run it again. Sorry, clear extreme Firefox, and then ampersand. So that will spin it off in Firefox. But then I say, well, I could go now on the browser, and then on this other window, I'm going to just do clear screen here and say run top. And notice that Firefox will come out at some point here as a process. But it's much easier, like you see this one process, a Firefox. And then that's the process ID of it. But top does not allow you to option to kill it. So htop does, and then process command does. So ps minus ef grep minus I Firefox. This is the list of Firefox process. One way I did it with pkill. Another one I say grep minus v grep. It's only those process. Now I need to know if I on the old days if pkill command was not available to kill a process by the name, you have to trace all the processes that are there. So in this case, I would say awk and then print $2, and that would just give me all the processes. So here we did a pkill, and this is another way you could do a pkill command. So here I say while read PID, which is all the process, then I say echo killing the PID, and now, and then it is done. After that one, you say kill -9. This is the actual kill command. And then $PID. So $PID, and then I have to do done. So this while read PID, it goes through this. It goes through the first one, the second one. If there are 1,000 of them, it take care of them. So now watch, it's done. Unexpected done. So somewhere I missed the do. So I have to come in while read var. I missed the do here, and then I have to say do and then semicolon, because now let's do the command correctly. While this one PID, and then I say do echo killing the $PID now, and then I say kill -9 $PID, and I'm just going to say PID and this, and then done. Now it is killing all those, and as soon as it done, I did. Now if I look for ps -ef grep -I Firefox, and then Firefox, and then grep -v grep, this does not return anything. So you know that it was successfully done. So that's another way you could do it. One way I showed you is pkill. This another way is that the pkill command used to not be there. I would write my endline shell script to just do that one. And if you do it for the shell script, you have to pass on the name of the here as a $1, and then do take care of it within that one. It will just do for whatever name that you want to pass it on to the script. You know what I'm talking about when you know scripting. So the part that I want to do, one more thing here, I want to do the same thing Firefox here. You can see Firefox is saying that it's missing or killed here. So because we killed it. So in order to do that one, let's just call Firefox again. And then at this time, we're going to just go back to our command line here. And then on this one, instead of killing it from pkill or that process ID, we use the htop. So htop, as I told you, is a TUI kind of stuff. And let's see if we can see the bottom. No, I don't see the bottom, so I'm going to terminate this one. No, don't terminate it now. I want to just quit. And I want to do this one, and then I open a new one here. And then this one is small enough. So if I say ps minus ef grep minus I Firefox is still running. So I'm going to run htop, and then I could show you why is this one not seeing the bottom of the windows. Let me. Okay, so one instruction, oh yeah, it shows up here. For some reason, it was not showing up. So one way that you could do is search for the process. By pressing F3, you say, show me Firefox. And then now, as soon as you type in Firefox, it highlights Firefox for you. So then you say, okay, Firefox is highlighted. Firefox, and then ampersand. That's the process, and then I'm not seeing the Firefox process. Somehow the window is too small. So let me just quit out of this. I'm going to come back on this session, and oh yeah, Firefox will stop. That's why I'm gonna run this one on the host name here, Firefox without the ampersand. So it doesn't run as a background job, it runs as a foreground job. You can see Firefox is up and running here. And right here, I could say, go to, let's say, mywebuniversity.com/table of content.html. And I want to just go to directly to my book. So that could take you to table of contents for the book. And why is it too slow? Oh, so the www is missing here, I believe. Yeah, that should take you there. So here I have a lot of other options that you could learn, but for now, let's just get to this htop command. And we want to say, okay, on this one, we run Firefox, and Firefox is done. On this other window, I run htop, and I search for Firefox. So pressing F3, it's type in Firefox, and Firefox right away, it's finds it here. That's the one, and then I'm gonna go with let's see, Firefox, and at this time it just says search again, Firefox. Okay, somehow it does open it, but why is it not highlighting it? It's supposed to, when you press F3, it's supposed to highlight it for you. So a lot of the TUI stuff sometimes is because of the resolution, and other ones is not as easily observed and compared to Windows Task Manager that we looked at it. Every time we search for something, we found it. Here, it is a little bit different. So I'm gonna say, get out of this one, quit out of here, and then quit completely, and then clear screen. I'm gonna say run the ps minus ef grep minus I Firefox. So there's a number of Firefox process, but they're all spin off by Wahid, user Wahid. So I'm gonna say htop minus u Wahid. And now you can see that the process that are forked are these ones. So which one is the GNOME stuff and other ones? Let's see if one of them on the right, it says something with Firefox, it doesn't. So I'm gonna quit out of this and figure out why Firefox is not listed here. Firefox, and then the main process of that one could be one of these numbers here. Yeah, this number forked other ones. So 7265. So if I say htop minus p 7265, and then you can see that it is not opening that process at all. Let me just see 7265. I'm going to do 7346. 7346. And then 72. So htop is not catching it for some reason. Okay, I'm gonna become root here. I'm gonna do sudo su dash. I'm going to become root. What root? Now you have higher privilege to see other people's process. htop minus u Wahid, and then I see all the processes that Wahid, user Wahid is spin up. So most likely Firefox is one of those processes. If I go down deep right here, Firefox is all of them are here. And then you can see a process, 3 of them is coming. And then for each of these ones, if you look at the Firefox, how many other child process got created, you see the list is big. So since I have root access with sudo, now I could do a search for filter for this one, say Firefox. And then you can see that Firefox is selected now. And then Firefox is selected, and then that's the process right here, the last one on the bottom. So Firefox, and now I have this option of not renizing it or killing it. So I'm going to kill the process. I don't need to give it a different priority. So the kill is F9. I press F9 and it says, do you want to kill it with what signal? And by default, I told you signal 15 is the termination. This is gracefully terminating, but I want to do it with signal 9, which is kill, forcing it with 9. Signal kill is forcing it. So I'm going to do that one, and then Firefox is gone. And then no more process for Firefox. So if I ps minus e rep minus I, Firefox, it is no longer there. That is my grep command. So I say grep minus v grep command is not there. Now, if I go back here, the process on the Firefox is exited out because I killed it. Okay, so there's htop commands that you can do, and there's other things that we didn't discuss, like how to get the list sorted by. These are very intuitive. You just have to play it. And F10 is quit. So, for example, F10, pressing F10 is here. It exit out, but after you do htop F10, you have to press enter, and that would just by pressing F10, it does not exit you out. But if you want to do htop and then you queue, it also quit that one. So you learn about htop stuff, and if by default on Linux machine, htop is not installed. On the Linux Ubuntu or Red Hat, you have to install it. So with Red Hat, the version that you have, etc, Red Hat dash release, you see that it's, sorry, cat etc red hat dash release. You see it's a 9.2 on this one. And then if I just say OS dash release, the detail of it, it tells me all the information about the Linux version of Red Hat 9.2 Fedora-based distribution. So anything with Fedora-based distribution or Red Hat distribution is based on Fedora, or Fedora is based on Red Hat. You could say as Rocky, CentOS, Fedora 39, Red Hat, all of those ones, you have to use either Yum, depending on if it is previous version of Red Hat 7 or below, or if it's Red Hat 8 point something and 9, Yum is symbolic link to DNF3, and so it works with the Yum or DNF. And then when you do RPM also, Red Hat Package Manager, you say RPM minus QA, it will list all the RPMs that are on your system. So if you do RPM minus QA, grep minus I, for example, htop, the process that is installed, this one is the name of the RPM or package that needs to be installed. And if you do yum provides htop dash actually user ben htop, because when you do which htop, it says that it's if it's already installed, you will say, okay, what is the name of the package? You can get it from RPM -QA, like that. I wrote that one, or you could say yum provides slash user then htop. That will also tell you the name of the package and that, or top dash 3.2. And then in order to install it, you use yum install and then this package name by giving the package name once you find it. If this one is on your repository list, then automatically you can get it installed. If it is not there, then you have to use subscription manager to allow it, and the repo name is epal, so it is by default there. So if I just say repo yum repo list, it will get the epal right here. It is there. That's why when I say yum info htop or yum list, for example, list htop, you could see that it is showing you all the details about htop processes. If you do yum search, it gives you the more information. If you want to say info, for example, it will do this one. Similarly, whatever works for yum, it works for DNF. DNF repo list, you will get the same command, because which yum file user ben yum is symbolic to DNF-3. And then file user ben DNF is also some symbolic link to the DNF3, and DNF-3 is a Python script. So you can see that one. If I cut that one, it's about 62 lines or something. And then it's all the modules that syspath and other ones that are being used within Python to just import sys module and everything to do the work for you. So Red Hat versions are very, very extensive with library of C, standard library of C, and also Python. Whenever you upgrade it from one system to the other one, make sure that you take care of your Python version 2.2.7 or deprecated. The old version, Red Hat does not support old compilers with old interpreters, and they want to just deprecate those ones, because when the operating system is end of life, you have to stay with the latest and greatest software. So we say that yum and DNF is interchangeably, but at some point they may deprecate yum and you have to use DNF. Until that happens, you can use both. So that is for Red Hat version, and then I believe you could do the same thing on Linux Ubuntu, and that's also so easy. I'm going to just go through them very quick because we already covered. And as you can see, htop is running here, and then same thing is for a processor here, the memory. Notice this one, and instead of 16 gig, we have 8 gig. So whatever I have allocated on that virtual machine, it will show those ones and the process service. And then if I do a PS3 on one, notice that this PS3 on the other command I could also show you. It doesn't matter which one do you do. With PS3, you have a number of flags that you can do. For example, if you want to just get the name of the flags, the threads, you could say -T and then get the threads name. And then if you want to say -P for the process name and number, you could also the process number. And if you want to do with uppercase T, don't show me that thread. Let me see, PS slash dash help, PS dash help, dash help, and then clear screen, not PS3 dash dash help. So you can see that there's a number of options, and dash uppercase T is hide the threads. Lowercase show the threads. Some of these ones, the lowercase is interchangeably used for showing or not showing. And then dash L for long listing and so on. There's a lot of these arguments, even with the -U for Unicode characters. Notice if I just do something like this and say PS3 process 1, it is showing all of that. And if I just say -U and then P dash P for process and then 1. Notice that this dash Unicode character, depending on which one you use, it's either an ASCII or this. Notice it's really nicer here the way that the Unicode is formatted for you. So depending on whether you do it on Red Hat or other ones, your output may look a little bit different, but these are your tools, and that you have a number of them, you could use them. Similarly, if you do like htop -U Wahid, the user Wahid processor showing there. And then similarly, if you do top -U Wahid, all the process for Wahid user Wahid is run. Similarly, for root, say top -P1, you will see process 1. So if you look at like top -P1, 2, 3, those ones that list of them on this one will show. On the Linux Red Hat was not showing. So that is something between the Linux version. Each flavor have a different way of pulling the data, but I have worked with all of them, and I know there's a little bit anomalies, but you have a lot of other commands that you can just pull the data that you want and interested on it and enjoy it. Okay, I'm not gonna go further than this, and if you have any question, please just put it on the video as a question. And if you appreciate watching these ones, please make sure that you return the favor by subscribing to our channel, and then give us a thumbs up and saying that good job, well done, so I can continue on making these videos for you. Take care. God bless you all. Bye bye.